Well, good morning, everybody. Let's get started for this month's Fuel webcast. I'm Dan Soller, Group Product Manager for Filter Systems, and I'm here today with Aaron Keck, he's the Application Engineer for Fuel. So today, what we have planned is new products, and those new products cover the inline bulk diesel filtration. So on one hand, the BDS4, and they are all for higher flow rates. So the BDS4 up to 280 gallons per minute, and then the LVH, which is the low viscosity housings. So these are vessel type filters. The F, particulate filtration, goes up to 950 gallons per minute. And the C, C stands for coalescing, water removal, they go up to 480 gallons per minute. Then we're going to close with an overview, so just put everything into perspective to see where the new products fall and the whole range of bulk diesel filtration products we have. And then we're going to close with some marketing material, just a reminder about our catalogs and the web page we have. So let's get started with the new product. And before I start talking about the BDS4, let's remind everybody about the BDS family we have so far, because the BDS4 is the latest and final one in the whole product family group we have. And we started out with the BDS, which is a unit for 70 gallons per minute flow rate. So that's the maximum flow rate for that particular filter. And it is a combination of a particulate filter, so a QF5, and a coalescing filter, the QCF. So we are removing particulates, and in the second stage we are removing the water. Then we expanded on this particular concept, the BDS2, which is doubling the flow rate to 140 gallons per minute. And the way we are doing this, we have one particulate filter still, which can handle the higher flow rate, so there's no problem there. But the coalescing filters, we add now two, divide the flow. So each of the coalescing filters really only sees 70 gallons per minute in order to achieve an efficiency, a water efficiency rate of about 99% or better at full flow rate, which is really the key to our filters. And we don't want to exceed the flow rate for the coalescing filters in order not to jeopardize the efficiency of the water removal. Then I think end of last year we had the BDS3 introduced, which again expands on the same concept. So now we are capable of handling 210 gallons per minute flow rate. And the concept is one particular filter, again, just one, you can still handle the higher flow rate, and 3 coalescing filters. So each of the 3 sees the 70 gallons, 3 times 70, hence the 210 gallons. They're all rated for 100 PSI. Now the BDS4, that's the newest addition to the family. It is going to be the final addition to the family. It can handle 280 gallons per minute, so another 70 over the BDS3. And again, one particulate housing and 4 coalescing filters. And the limits right now is really on the particulate side. We would need, for higher flow rates, we would need to have 2 particulate filters. So we decided this is where we stop with this particular concept.
Dan, I frequently receive questions about how we're able to achieve higher flow rates with what looks like stacking more housings in series. And we've received some competitive feedback based upon that, saying that we may see suffering and efficiency because we're passing through these filters in series. Can you help explain that?
Sure, because I think some people actually think it's all in series and we just go through the first and the second stage and so on, which is actually not correct. So on the next slide, I hope I can shed some light on how it works. We really have 2 stages. The first stage is this particulate filter, which always sees the full flow rate. So the incoming fuel, and for the BDS4 it would be at 280 gallons, would go through the first stage, the particulate filter. And then it goes into the second stage, and now here we have 4 coalescing filters, QCFs, which are actually parallel.
Okay.
So now each one sees the 70 gallons per minute flow rate. So this is not exceeding the capabilities of the individual filter. So each one takes the 70. Then on the outlet side, a customer can either hook up each individual housing and get the 70 output, or combine, as the big red arrow indicates, combine back to the 280 gallons per minute flow rate.
Okay.
And so this is the way we achieve it, and this way we can assure that the efficiency, the water removal efficiency, is not jeopardized in any way. Now to the model code. So the BDS4 follows the BDS3 model code really, because it's the same family. So the BDS box 1, then the box 2, the 4 indicating the 280 gallons per minute, hence 4 coalescing filters. Then box 3 gives you a choice for the particulate element, the micron rating, either 1 micron or 3 micron. Then box 4 is the seal material, because we're dealing with fuel here, so white on, that's standard. Then we have a dirt alarm, it's a visual pop-up, that's standard as well. And box 6 gives us all the other options, either omit, then we have no additional options, or you can choose sump heater or a side gauge. Then we have automatic water drain, the AWD, either with a 5-gallon tank or a 20-gallon tank. Now for the bigger models, probably more like the 20-gallon tank, because over time you don't want to probably need a big enough tank to accommodate the setup. And C stands for the flow control valve. So in order not to exceed the maximum flow rate of 280, with an additional optional flow control valve, you can basically assure that you would restrict the flow in this regard. Now, those options essentially are available for all the BDSs in the entire family. So from the BDS up to the BDS4. So that's H for sump heater, S for side gauge, AWD5 or the AW20. And the control valve are 2 sizes here, either a 2-inch or a 3-inch flange. So the 2-inch is used for the 2 lower, one for the BDS and the BDS2, and the 3-inch is used for the BDS3 and the BDS4. Now the other new product we like to introduce or reintroduce really this time around is the LVH. So LVH stands for low viscosity housing. Now fuel is low viscosity, that's the application range, and it's really intended for diesel. So it's not for low viscosity hydraulic fluids, it's entirely intended for diesel. Now the change we made, we have now local production here in the US, which gives us 2 advantages. We have improved cost, so we were able to actually lower the cost and the price for those units. And the lead time, because it used to be overseas, now it's over here locally, so we have a shorter lead time to deal with. Now those housings, they go up from 200 gallons per minute flow on the low end, up to 951 gallons per minute flow rate. Now ideally, an application really for those LVHs would start at 300 gallons per minute flow rate.
Okay, so Dan, given that that comparison between 200 and ideally 300 gallons per minute flow rate, can you help explain why we would see a benefit in that compared to the BDS product we previously discussed?
Yeah, if you're in the range 200 or let's say around 280, so the 210 would be a BDS3, 280 would be a BDS4. So as you pointed out, you have now an option, you can go BDS or LVH. Now, if you compare the cost, the BDS4 actually has a cost advantage because it's one complete package, while you need an LVH, you need 2 housings. You need a housing for the particulate filtration and you need a housing for the coalescing, the water removal.
Okay.
And besides the compactness or the price, if you take a look at the size of the LVHs, they're going to be actually much bigger in size in comparison. So these are the 2 advantages why most likely you would go on the lower GPM side, so the 200 to 300, you're probably more likely going for a BDS4 or a 3. However, the LVH vessels, the housings, are actually now available ASME standard.
Right.
Now, if this is a requirement, then obviously you would go for an LVH.
Really excluding the BDS product if an ASME
Yes, that's
is
true, right.
required.
And I think LVH in general, I think it's probably true to say that if we have a project, it probably has to be discussed. I don't think somebody's just buying the product out of the catalog. In those flow range areas, I think it's probably more customized solutions which we need more discussion with the customer to see what is the best fit.
Okay.
So as I was saying, the ASME U-stamp is now a standard for the LVH. Again, that's right now available only on those LVHs. Then the LVHs have an excellent filtration performance, which is a trademark of Schroeder no matter what. I mean, that is our core business. High dirt holding capacity as well, so for the particulate elements in the LVH-F.
How much dirt holding capacity are we speaking about?
In this particular case, if I look at one element, and you will see later that depending on the size of the units, we have several elements in there. If I'm looking at one element, and I'm looking at the maximum flow rate for that particular element, the dirt holding capacity is somewhere around 3,000 grams, so 3 kilo.
Okay.
Versus if you're looking at the BDS4, so the particulate element in there has about 1,500. Right. So the LVH gives you double the dirt holding capacity, okay, at least. And then for some of the units, the starter unit, it's double. For the bigger units who have more elements, it's even more. Which is actually another point. If you need high dirt holding capacity, it might be the LVH, that's your choice. Right. Then low pressure drop overall, because of the vessel design and the element design. We are just talking even full flow rate, even for the biggest units. We are just talking about 5 or 6 psi actual pressure differential when the units are in use. Here you can see the two versions we have. We have the LVH-F, which is a particulate filter, and we have the LVH-C. C stands for coalescing, that's the water removal. And the F type goes from 211 up to 951, so that covers the full range. The C type goes from 211 to 476. And then if you want to pair it with an F, you would need 2 of a smaller to achieve the 951 gallons per minute flow rate. Now those vessels in general are rated at 150 psi, so slightly more than a BDS. That might be even another advantage.
Absolutely.
Which I don't think in normal application you would even see that. 100 psi might be enough to cover the application. So, talking about application, the LVHs again, or the higher flow rate units in general, are really intended for bulk diesel fuel transfer and at higher rates. So, you know, if 16 gallons is not enough anymore, really, if you're talking 100, 200 gallons, higher flow rates,
right,
then this is where this comes in for loading, unloading applications, or for point of use, for dispensing. So the markets which come to mind, production, fuel, refineries could be a point, distribution, or service. So fuel dealers, for instance, they might be interested as soon as they are really handling a lot of flow. And industrial, the markets in general, industrial, marine, mining, power gen, agriculture. We can really look at all the different markets. The question is somewhere where somebody's handling higher fuel rates.
So I guess to better understand that, can we look at maybe an example of a specific, maybe in mining? Filtration as to an ideal target?
Yes, mining, above ground mining. So basically you have the trucks running around, they need to be fueled and tend to be big. So the tanks tend to be big too. So you want to refill those quickly. So suddenly a dispenser flow rate might be, it could be 100 gallons per minute flow rate or more. So suddenly you need something. But a regular dispenser somewhere for a car refueling station might have 8 gallons. So obviously that's the difference in size and application.
So this really fits the BDS and the LVH into that.
Yes, so the starting point, that's the point, right?
Great.
And again, I think a good target in general will be dealers, fuel dealers. And that's a good starting point and to help them, especially on the particulate filtration. Very often I would say the fuel is not going to have water in it because if it's being refined and being consumed, water might not be an issue, but particulate is still an issue. And that's usually the first point of attack. Now if somebody has a tank and it's just sitting there and the fuel is not being moved for days or months, then yes, the tank could be swelling, and you could have actually water accumulating in the tank.
Right, and I think we've seen in some cases where fuel supply is provided by maybe a marine source, that water aggression is just inherently part of that process.
Yes, that's a good point. So the environment has especially if the fuel is lingering around longer and you have a humid environment,
Right.
then obviously it can be important as well. I think it's always a good idea to cover both the particulates and the water removal, and then the customer should be in good shape.
Absolutely.
So now let's have a look here at the specifications for the F. So the flow rate 211 to 951 GPM. Inlet and outlet, we have flange connections, choices from 2-inch to 12-inch, either DIN or just NC flange connections here in the States. Maximum operating pressure 10 bar, so the 145, so 150 psi. Ambient temperature 122, and maximum temperature of the fluid, it can be up to 158, so it can be higher than the actual ambient temperature. Material housings, either stainless steel or carbon steel, and ASME housings, or U-stamped, they are standard, so that's what you're going to get. If you choose not to have it stamped, it's not going to be cheaper because it's already included. And CRN or AS1210, so all those other codes for other areas, like in Canada, are available upon request.
Right,
So
and I certainly wouldn't limit us to just CRN and the AS Australian stamp, but if there are other necessary requirements,
Right.
we can certainly provide feedback based
Yeah.
upon your application.
I think we can work with our vendor, and because they have experience in this, so I'm sure they can accommodate even some crazier standards out in the world.
Absolutely.
Okay, so housing element configuration. So we have the LVH-F for particulate removal. One is indicating the amount of elements we are using. So it goes from 1 to 3, 4, 5, or 8. So the biggest unit for the highest flow rate, 951 GPM, has up to 8 elements included in the vessel. And then those elements, you have a choice from 3, 5, or 10 micron rating. So just to give you an idea about the dimensions, from the small one, the F1, up to the F8. So we're looking at 19 inches between the two flanges versus 35 inches for the big unit between the two flanges. So just that's the width of the unit. And then overall height, 86 inches tall versus 95 inches tall. So they're about the same height, and just the width is changing depending on how big the vessel is to accommodate all those different elements. Then in the first slide we have seen the vertical units, which are standard units. Now we have some available upon request, horizontal units, especially if they become bigger, it might be an advantage to have them horizontal. So we have an F1 type available and F4, and the others we would have to see. Right now I think we don't have the drawings ready, but that's something we can work with our vendor as well, and at least have a look. So here is the model code. So box 1, LVH, F for a particular type. Then we need the size, the number of elements. 40 is the length of the element, that's 40 inches. Housing material, either carbon steel or stainless steel. Then the mounting, as I was saying, vertical is really the standard, or horizontal. Pressure rating, 10 bar is standard. Now you can have it 16 bar. So if for some reason you have requirements that have higher pressure, it would be possible to go to 16 bar. Then the connections, that's the flange sizes that would be needed, and the NC type flanges are available upon request. Then white on seal, because it's for fuel. We have clogging indicator options here, several ones. And at the end, ASME certification, again, that's going to be a standard, but it shows in the model code.
Absolutely, and Dan, I guess to remind everyone too, it slipped my mind, but marine-based ABS standards are also available for the LVH vessels, so
Okay.
just keep that in mind as a contact factory available option.
Okay.
Regarding the elements on these housings, I can see us being asked this question in the future, are the elements included?
For the LVH, they are not included, so the customer would have to order them in a separate line item, and then they can choose between the 3, the 5, or the 10 micron. And this basically doing this for competitive reasons, because our competitors are not including them as well. And in this way, we can keep the amount of auto codes to a minimum as well.
Sure, so that's in contrast to the BDS product, which does include...
True, that's a good point, yes.
Okay.
Because there actually the element is part of the model code. So in this particular case for the LVH, that's not the case. So.
Okay.
Now let's have a look at the other type, the LVH-C, so the coalescing unit. Here the flow rates go from 211 up to 476 gallons per minute. Again, you have the same type of connections, either DIN flanges or NC type flanges. Operating pressure, 10 bar, as a standard. Then ambient temperature is the same, 122. Now in this particular case, the fuel should not exceed the ambient temperature of 122 degrees Fahrenheit or 50 degrees Celsius. Because in order to remove the water, it's not good if the fuel is actually too hot. It doesn't really help the process. Material housing, stainless steel and carbon steel the same. Here the same applies for ASME, U-stamped code, and what you were mentioning, availability of other codes as well.
Correct.
So it's the same type of vessel, just the insides are somewhat different and the configuration of the elements are different, which we see here. We have 3 different sizes, right? But it starts with the CD4, which indicates we have 4 coalescing elements and 3 separated elements. This is the low-end unit for 211 GPM. And then 6 is accordingly, we have 6 coalescing elements and 4 separated elements. And we have for the 9, at the highest flow rate, 476 GPM, we have 9 coalescing elements and 6 separated elements. And then those separated elements and coalescing elements, the separated element is 30 inches tall, the coalescing element is 40 inches tall. There's one type each, so there's no choice here because it's about removing the water.
So yeah, I can see some confusion in being the fact that there's a separation element and a coalescing element. I guess just to clarify, do we need one, the other, or both?
We need both. So basically what we're doing in a coalescing effect, the first one, as it says in the name, the coalescing element, what it does, it combines small water droplets into bigger ones, and then eventually those bigger ones might even fall down by themselves through gravity.
Sure.
But no matter what, it's going to hit the separator, which is essentially the barrier. And the barrier or the separator element assures that no water goes through. So you need both. That's the natural setup.
So different than our BDS product where we have all of those layers built into one element. In this case, it's just split into 2 separate elements.
It's essentially split into different elements which have the different functions that combined allow us or give us this coalescing effect.
Great.
Then one other point to mention here for the LVH-C, the C is coalescing. That means we are removing water only.
So you're saying we don't address particulate filtration in this case, right?
No, yes. If you have an LVH-C standalone, this is really not intended for a standalone function because it only addresses the water.
Okay.
The particulates are not really filtered. What's going to happen is the particulates might be randomly removed, especially the bigger ones, and it's just filling up the elements. But there's no really a control over it. What you need is a combination of an F, first stage, particulate removal, and then the C, second stage for water removal.
So much like we're doing with all of the other fuels, bulk fuels product that everyone may be familiar with, we're adding particulate first, coalescing second
it's the same principle.
as a package.
Right, and it's the same act for the BDS4 essentially. While there the whole package is given,
Right.
here it will be 2 housings that have to be combined.
Okay.
And in so many cases actually a customer might prefer just to go with a particulate filter, so an LVH-F. Right? So the C type might be actually an option, but it's not really, you're probably not going to see anybody just having LVH-C in place. They might have auto filtration for particulate removal, then yes. But you always need somehow to protect the coalescing filter and remove the particulates as well.
Great.
Then here dimensions as well. Now this setup with all those elements that have to be in one vessel, obviously the vessels get larger. They tend to be larger.
Sure.
So the CD4, which is the smaller one of the 3, has 40 inches between the flanges, so that's the minimum space you would need to put them in. And then the LVH-CD9, which is the larger vessel, is about 12 inches wider, so it's 52 inches overall between the flanges. Now the overall height of the vessels don't change much because we're still dealing with those 30-inch and 40-inch elements that have to be in the vessel. So 91 inches tall for the CD4 or 100, so slightly taller for the CD9. Then same here, same principle, the vertical ones are the standard. If you need horizontal housings, we have an LVH-CD9 right now, concept. All the others right now we don't have concepts, but if needed, we can work with our vendors to get it done.
Right.
So finally here the model code, it's similar to the F-type model code. So we have an LVH, CD now, box 2, indicating coalescing for diesel fuel. So the C is coalescing, the D stands for diesel fuel. Then box 3 explains the setup for the different elements. So 4 and 3, or 6 and 4, or 9 and 6. Then the filter element is still 40 inches for the separator element. Then housing available stainless steel and carbon steel, that does not change. The mounting vertical standard, horizontal is available. Pressure rating, this one is only 10 bar. There's no higher pressure rating available for this one. Then we have the same setup for the flanges. We have the seal, F for white tone, same clogging indicator options, and in box 11 at the end, ASME certification, so to identify it's a standard, but to identify it is ASME U-stamped.
So in this case as well, are we looking at having to purchase the elements separately?
In this case, it's the same. It's not, the elements are not included, and again, this is more driven by competitive reasons for pricing, starting price or list price issues where we can be more competitive that way.
And I guess to answer maybe some questions while we're on the topic of cost and pricing, I know that I'm sure it's stirring in people's minds the topic of ASME, and in this case, you know, we're ASME U-stand vessel. Typically, ASME vessels are seen as a more expensive product. In this case, do we see, I guess, from our vendor's source, do we see a benefit from the designs already being ASME structured? So you don't see a cost benefit from not
There's
being.
no cost benefit because the ASME is standard.
Right.
And our vendors are set up to do this, and all their approval they had to go through, it's already paid, so it's already mixed in. So there's, even if you order one that's not ASME,
Right.
there's not really a cost advantage to us. Therefore, it doesn't really show up in a difference. So no matter what, the ASME approval is there. Now, on one hand, we can say we can highlight it or not, but it's always going to be there.
So we should actually, it's almost like an added bonus of being able to get an ASME vessel for really a more competitive cost.
Right, especially if you're competing against somebody else where the requirement would be that it doesn't have to be ASME,
Right.
and somebody else is actually offering product that is not. We are now competitive in pricing, and we could actually use this as another advantage.
Great,
That's what.
great.
Because it gives you safety, and you know the thing has been manufactured at a different level.
Right.
The quality is better, probably. So it's a quality seal, if you will. Then let's have an overlook and see how do those two new products fit. And just as a reminder for the rest of the products we have. So the bulk diesel line, inline filters, it's all started with the ICF. That's our core, and then the QCF is the bigger one. But the ICF itself, that combines all three stages in one element. So we have a particulate removal and we have a coalescing water removal with the two stages, the coalescing and the barrier. Now this can be used alone, but then the element becomes a consumable because it's going to fill up with dirt. And unfortunately, coalescing elements are not inexpensive to produce. So it really makes no sense to go through usage. Actually, it's better to combine them in a particulate filter with a coalescing filter. So like the BDF1, which is at 16 GPM as well, combines a particulate filter, and now it removes all the particulate from the fuel, and really it protects the ICF that's on there in the second stage. So really the particulate element becomes the consumable, while the ICF really doesn't need to be changed maybe once a year. Then the BDF2, same concept, we just have two ICFs on there dividing the flow. So here again, each of the ICFs on a BDF2 sees 16 gallons per minute flow. 16 times 2, that's the 32. Then the QCF, that's the big one, up to 70 gallons per minute. And we combined those, which we saw earlier in the BDS family. So from 70 up to the BDS4 at 280 GPM. And now for more higher ends, so 300 GPM up to 467 or 950, we have now the LVH-F and the LVH-C to complete the whole package. Then on the mobile side, we have filter cards available as well. And it's the same principle here. We have an ICF, we have the QCF as a basis for water removal, because in diesel fuel handling, it's about particulate removal and water removal. And this is really where those coalescing filters come in. So we are using the ICF on a BDF-C. So really it's the BDF1 that's being put on a frame with two wheels and a pump motor group. This one is now running at 40 GPM. And the QCF is combined in a BDC, bulk diesel cart, with a pump motor group running at 25 GPM. And there's actually another stage. The first stage is a bag housing or a bag filter. Now if you have a scenario where you need to maintain a tank that hasn't been cleaned in a while, it tends to be very dirty, and it tends to have some nasty stuff in it, like bacterial growth and fungus and whatnot.
That sludge.
The sludge, right? So actually the bag housing comes in very handy. It's an ideal scenario to clean up messes you created over the years.
Low-cost consumable.
And yeah, it's just a few bucks for a bag, or for a bag, right? So it's much less cost than an element would be. And really, and even if it's cleaning up originally, after a while, just to get the most of the dirt out, just go through a few bags, and then eventually you can just
do a fine polish.
Yes, fine polish the fuel. Now the 25 GPM is because it can be hooked up to 110 volts anywhere. Any power outlet you will find will accommodate this card. So that's the reason why it's limited to 25 GPM. Now I think earlier this year, March or something, around a couple of months, 3 months ago, we introduced the BDC at 70 GPM. So we have a BDS on there that can handle 70 GPM, so it's a shame not to use that. And we decided, let's go all the way, have a mobile unit that can handle 70 GPM, but it requires more voltage, so a little bit more power behind it. So now you need 230 or 460 volts somewhere. But that allows us to go actually to the 70 GPM full flow rate. Otherwise, it's the same setup. It just now it's a little heavier because it's a bigger motor and bigger pump. So we decided to put it on a more sturdier frame. So that's the footprint gets a little bit bigger. And before I close today, let's just have a look at the marketing material. So we have our fuel filtration catalog that's available online. We added the BDS4 and the LVH information catalog pages. Then the brochure for bulk diesel, which in my book is still the nicest thing to make an introduction with a customer. It's just a little leaflet, 4 pages, but it explains the need for fuel filtration and just a handful of products to show to a customer quickly what we have to offer. And again, why it's important, Tier 4 today, and all those requirements. That's usually a good starting point. And then with the second visit, you can go into more details and put the whole catalog on the table. And then finally, the website has been updated with the BDS4 and the LVH. So I tried downloading those catalog pages. It worked, so that's all good.
And I guess the age-old question that I'm sure everyone is waiting to ask, when is the pricing available for the BDS4 and the LVH product?
Yes, that's a good question, and we are working on it. We couldn't make it on time for today. There's still a couple of items we need for the LVHs, but we're going to have, in 2 weeks, we have everything going to be available. I mean, the BDS4 we have already, it's just we're waiting with uploading all this information if we have everything combined in 2 weeks. If somebody needs pricing today for the BDS4, we can already provide that, that's not a problem. And most of the LVHs as well. And in 2 weeks, what we're going to do is we're going to be providing an update and the LVH pricing for the smaller units. So for the 211 and 317 gallon unit, maybe the 476, we have to decide on that as well. Because the smaller units are more likely to be just sold directly out of the catalog. If you go to the bigger units, the 632 GPM and the 950 GPM units, we don't think that somebody is just buying one out of the catalog. That's going to be customized projects anyway. There's going to be more involved than just the individual vessels or housings. So for those, we just have it going to be in the price list as contact factory. But again, we're always here when you need information or have questions or need some pricing or even ballpark. Just give us a call and we can provide this at any moment or any time. And this is it for today. Hope you have a great time. Till next time, talk to you then. Thanks. Bye-bye.